All right, I think it's recording. Awesome. Can everyone see the slides? Yeah. Okay, awesome. So hello to all the burst members. Thank you for coming to the final workshop that we have this year, and it will be the first part of our Intro to Coding workshops. This time we'll be talking about Python and C++. And so without further ado, I'm going to get started. And so a few reminders, the sign-in form and the QR code is going to be put in the end of the workshop. We'll have a slide for those. And so hang tight till then. This workshop will be recorded, so if you need to go back to it, you can go onto our Burst YouTube page where we'll be posting it probably tonight or so. And bring out all your questions today. You can unmute or chat in the Zoom chat box, and Daniel and Warren are more than happy to help you all out. Okay, so I'm going to give a few introductions. First one, so Daniel is currently at Flatiron Health, a healthcare company, and he works as a senior software engineer in New York City. And in the past, he worked at Fair Harbor and Zenefits as a full stack engineer and platform engineer in San Francisco Bay Area. And he received his bachelor's at University of California in Los Angeles for computer science. And he will also be talking a little bit briefly about his past work too. And Warren is currently on my academic committee member team. He is a freshman, and he is currently working for his bachelor's in computer science and is on the software engineering track. And his coding experience is mostly C++ and Java with a more emphasis on C++. And he taught a few coding camps at St. Mary's University in the past over the summer breaks. And so today he'll be going over C++. Okay, so without further ado, I'm going to stop sharing and let's see. Daniel, I'll let you be the co-host and then we can get started.
All right, hey guys, I'm actually going to paste a link in the Zoom if it's going to let me. Let's see, where do I do that? Why is it not? Or maybe I won't. Maybe it won't let me. Oh, here's the chat. All right. Here's a link to what I'm going to go over today. So if you guys want, you guys can follow along there. Otherwise, I'm just going to share my screen. I'm just going to talk mostly word for word, but there's actually going to be some demos, so we can go along. And I just wanted to give you guys, a brief overview of how Python works, some things you can do with it. Hopefully, get you guys excited about Python, really. So a little bit about myself. So I'm Daniel. I'm a senior software engineer at Flatiron Health. Sorry, should correct it a little later. So Flatiron right now, its mission is to learn from the experience of every cancer patient. For me, I work on the Scans at Scale team, where we, one, enable physicians to view medical scans. Those scans are like PET, CT scans, MRI scans at the point of care with patients through our EHR or EMR software. So if you guys are familiar with hospital software, that's what they call it, EHR, EMR software. And also, we also enable research teams to understand how we can use scans to help with, for example, earlier cancer diagnosis or speed up the approval of a cancer drug. So, for example, patients get diagnosed with cancer every day, and as a part of the procedure, they might get a scan every few weeks after taking a new drug. Each scan might have what we call a slice thickness as a field that we can pull and extract from that scan, which measures that image data quality. And if that scan doesn't meet a certain slice thickness criteria, the scan itself cannot be used as proof that the drug that the patient took has worked or not. So that's an example of how we use Flatiron scans data to try to learn from every cancer patient at the end of the day. So that's really the mission of Flatiron Health. So that's my brief introduction. I kind of want to go over a little bit the outline of what I want to talk about today. So first, we're going to go over somewhat briefly the things that I love about Python. This is definitely not an exhaustive list. At the same time, I would say that Python, everything that I talk about, it's not necessarily going to be unique to Python. But these are definitely things that you can get with Python, which is very, very nice. And that's why I love it. We can also talk about what you can do, what you can build with Python. same things apply. You can definitely do these in other languages as well. But I want to give you guys a flavor of what that code looks like, what you can do with it. And at the very end, we're going to talk a little bit about the additional resources, things like where maybe you guys can start and things like that. So let's get started. So things I love about Python. Maybe you guys heard of this already. Python reads like English. I have a little example for you guys, but it's very easy to get started with Python actually. And I'm going to pull up a very, if you guys have a MacBook, which I do, not everyone does, but some people have been hating on it recently. So here, actually, if you type in terminal here, this will pull up a window that looks like this. I have a very special one. It's called iTerm. It's an application you can download. If you Google iTerm, you'll be able to find it. But it's the same thing, terminal, but you can actually just type in Python in your terminal right away. And what this does is it launches an interpreter. You can start issuing it commands. So you're defining a variable called a. You're setting a equal to 1, b equals to 2. You can do simple things. A plus b, 1 plus 2 is 3, right? So what we call this is a REPL, read, evaluate, print loop. And so I'm just going to terminate this because I like my environment better. I'm going to type in IPython, which is also relatively the same. And same thing as typing in Python into your terminal if you guys want to get started. Right here, I have a very simple snippet of code, and I want to read it with you guys just to give you guys a sense of what that code looks like in Python, right? And this is totally made up, I'm sorry, on the spot. And so if it doesn't really make sense, well, go with it. So here's the code. We're going to just briefly look at it for a second. And earlier I thought about robots and it didn't really make sense. So I changed it to T-Rex because I recently watched Jurassic Park. So here is, there are actually quite a few things that are going on in this snippet that we call. First of all, there might be some modules or packages that we need to import. Maybe some people wrote things that we can reuse. In this case, it's a random library, right? And a class, if you guys have heard of object-oriented programming, you're essentially defining a blueprint for creating future, in this case, T-Rexes, okay? And so future, when you're actually creating a T-Rex, they will inherit a lot of these properties, right? So we're going to talk about that as we go through this. So in the very beginning, you can define things like this, class T-Rex. You're saying T-Rexes will always do this when I create a T-Rex. Well, they're going to start off with health equals 5, right? So a T-Rex is going to start off with health equals 5. What else can they do? They can jump off a cliff. I couldn't think of anything else, so I wrote jump off a cliff. Well, when you call that, you can print some things. You can note, hey, he lost 1 health. And maybe there's another function that says, is it alive? Is this T-Rex alive, right? So this is pretty readable, right? From any point of view, I think. Over here in line 16, this is where we're actually creating an instance, that's what we call it, of that T-Rex. So we have a blueprint of the T-Rex. We're creating 1 T-Rex here. This is the first time we're actually creating the T-Rex. And we're going to say, while we find that this T-Rex is still alive, technically this should be is alive like this. You can do that. And obviously it'll be that because it's returning some sort of true or false value, right? We're going to generate a number, a random number. And if that random number is greater than some sort of number, then the T-Rex is just going to jump off the cliff. So hopefully that was pretty readable. Maybe I'll give you guys a couple seconds just to process that, hopefully. Okay. And here we're going to just print out the health of the T-Rex and see what happens, right? And at the very end, we assert. Assert is like testing your code. So after you've written some stuff, you want to make sure that what it's doing is exactly correct, right? So the nice thing about Python is this REPL that I mentioned earlier. And you can copy this code into this REPL. You can type in %paste, or there's a, %C paste. All right, you can see that it's evaluating, right? And I just wanted to illustrate some things, right? So in certain languages, you have to actually build the code before you can run the code. And right here, it's just reading your code that you input. It's evaluating it right away, right? REPL print, it's printing as we go, and it's a giant loop. The loop is, after it's done printing the output, it just loops back into read, evaluate, print, and loop, right? That's why it's called REPL. So now I kind of want to go into the next part, which is the idea that it's pretty easy to debug. And here we're going to just, to illustrate how it's easy to debug, you can actually add code such as this, import PDB. PDB is another package, pdb.set_trace. If you guys have used a debugger ever, you can just throw it in here. Again, copy the code, paste it into the terminal, and guess what? There's your debugger right there. This is very useful because let's say you're working on a big program and you just want to test a little piece of it. If you have your terminal open and you copy it in, you can just test that little function or whatever you're working on right then and there, right? And as you interact with the debugger, let's see, next means the next line. We have the random number, let's print that out. Random number is 3. Is it greater than 2? Let's make sure that it jumps off the cliff. You can type in step. Step will jump into that function. I'm just gonna put this function side by side here. You can see that jump off the cliff, right? Well, it's gonna jump off the cliff. Hopefully you guys can see that. Press next. You can see that we're gonna fall off the cliff. We're gonna print out the health. It's 5. We're gonna subtract 1, right? All right, it's gonna return from that function and it's gonna go right back into here where it finishes. It's gonna return right back there. And it's gonna go right back into that while loop. So hopefully this is readable. Hopefully you guys can follow that. And obviously there is a bug, right? I'm actually not gonna solve it because I just wanted to illustrate that it's easy to debug and you can write code, you can do a lot of things right here in this REPL. That's what we call it, it's a quick feedback loop. This is definitely one of those things that I absolutely love about Python. You can type things in, test a little piece of code, you can easily debug things, right? And I think this is underrated, but a lot of big companies use this, use Python. Google, Dropbox, Pinterest, Instagram, Reddit, right? I'm sure all of you guys are at least somewhat familiar with some of these services. So I just want to call out that this is definitely widely used and the adoption curve is actually going higher and higher. More and more people are learning Python. It's definitely very easy to pick up. Cool, I'm gonna pause for a second. Do you guys have any questions? I don't know if I can see the room, so I'm gonna see. Okay, no questions. Okay, that's cool. All right, if there's no questions, I'm gonna move on to the next section. So now we're gonna talk about what you can do with Python. This is definitely, again, it's not necessarily unique to Python per se, but these are definitely a broad range of things that you can do with Python. And I wanna touch on quite a few applications or use cases, and it's kind of jumping from place to place. And I've thought about some of these things before. So the first thing on the list, what you can do with Python, if you guys have heard of this term IoT, Internet of Things, right? So IoT, the dictionary definition, I pulled it out, refers to the billions of physical devices around the world that are now connected to the internet. So what are some examples of those things? If you guys can think about it, I'll give you guys 3 seconds. If you guys thought of Google Home, Alexa, actually there's one that I thought was really cool. I was actually interviewing for companies and I live in New York City and I see these kiosks actually all the time. If you walk around Manhattan, there's these kiosks, and what they do is they let you charge and use their Wi-Fi, charge your phone and use your Wi-Fi. It's pretty nice, but it actually has an additional function. And as I was going through the interview, they were mentioning that they actually keep analytics of foot traffic. So for instance, you might see this Arby's in this picture, right? How many people go to Arby's a day, right? That might be a question that some future investor who's looking at this building right here wants to know, right? So if this is a high traffic area, then potentially this is someplace worth investing in. And maybe we should buy this building or rent from this building. And so that's a good use case of, you see Link NYC, where they put kiosks all around Manhattan, all around different cities. I think it's in Chicago and a lot of major cities. And all they do is just count foot traffic, amongst other things, right? Other things I already mentioned: Google Home, Alexa, Raspberry Pi. Hopefully you guys have heard of some of these things before. I'm pretty sure you have. A Raspberry Pi is somewhat interesting. If you guys have heard of microcontrollers, where it's really just a small computer, and you can write some code, execute it on this tiny machine, and make it do things, right? And I wanted to walk with you guys some of the code for a sample Alexa integration, or Alexa, I guess, IoT, right? Connection, hardware connection. So I put some code here. We're just going to walk through it. You can see it says Alexa, skill sample, Python city guide. So hopefully this is easy enough. I actually don't know too much about it, but hopefully you guys can get at least the idea of this. And if you scroll down here, you can see this, what I found very interesting, right? So Alexa, if you guys don't know it, right, it's a smart device. You can interact with it. You can say things to it, right? Well, look at that, right? Here's a sample of things that you can do and interact with Alexa here. So, hey Alexa, recommend an attraction, or recommend an attraction within distance miles, right? So these are all templated variables, and those templated variables will eventually get interpolated, or point being that it's been defined somewhere and it's going to be inserted into here as the actual value, right? So recommend an attraction within 5 miles, right? And so let's think about the user flow of how this would work. So the Alexa is sitting in your room. Alexa, recommend an attraction within 5 miles. So that command right there is what we call an event. It's an event, right? So that event gets passed to Alexa. And guess what? There's some handler code, that's what we call it, request handler code. So it processes your request, and it's going to handle that request. It's going to say, hey, what did Daniel say? And you can see here, there's a bunch of different intent handlers, right? And let's just briefly go through one simple one, right? So I'm going to go through this lunch intent handler, and you guys can see it's pretty simple. It's going to say once it gets a handle, or once it gets, it's going to take your request, and we're just going to choose a random restaurant, right? Get a restaurant, buy a meal, or whatever this is. And here's the speech. Here's what Alexa is going to say. Lunchtime, here is a good spot. Whatever it is, would you like to hear more? Right. So this is a sample example. I like sample example, but of how you can interact and play with these libraries that essentially allow you to control IoT, Internet of Things, right? So Internet of Things, I think you can think of it as just any hardware device. It might be a little bit confusing, but it's really just a hardware device that you want to program. You want it to connect to the internet. You want to maybe give it instructions. Think of like clap on, clap off, the little light controller thing, right? So there's an event. Maybe in that case, the event is you clapping your hands. And it's going to handle that event, and it's going to process it, tell it to do something, maybe turn off the lights. Maybe it's a smart home, for instance. Those are things that you can do with a Raspberry Pi, okay? It's a general purpose little machine, little computer. Hopefully that made sense. I'm gonna take a pause. I can't really see. Okay. I'm gonna open this chat, okay. How do you program it to recognize other languages beside English? Yeah, this is a great question. I think, so Python is just a programming language, right? And I think English, obviously there's different linguistics and different, it's not a programming language per se. So there are actually a lot of times libraries, and I think that's why Python is so good for this, that a lot of these libraries that you can have access to can actually translate, allow you to specify what those translations are in those other languages, right? So I think if you think about Google Translate even, sorry, I was gonna, right? These are like, as you enter in text here, right? Hi, right? It's translating it directly into something. And maybe in Alexa, right? The fact that you're typing in hi is the event. And then you're gonna pass that event, or this event will essentially pass in whatever you typed. And it's gonna pass it maybe into a package library. Maybe that library will allow you to specify exactly what that translated word is, and or the speech, the exact phrase that you're going to use, right? So you can imagine, obviously, translation is a pretty difficult thing. And so oftentimes in the industry, they actually provide software such that you can specify exactly the words to be used and the phrase to be said. Hopefully that answers your question. Cool. Okay. No other questions? All right, let's move on to the next topic. All right, so the next thing is what we call infrastructure as a service. Okay, so this is a pretty loaded term, infrastructure as a service, platform as a service. There's actually a lot of terms for this, but if you guys have heard of, the cloud, cloud is something floating in the sky, right? It's just internet, maybe. But something is powering the internet, right? You may have heard of AWS, Amazon Web Services. You may have heard of GCP, Google Cloud Provider. Oracle has one, right? There's an Alibaba one. There's a ton of these cloud providers. That's what we call it. They provide the cloud, right? Infrastructure for the cloud. And I think infrastructure is also a loaded term, so we're going to talk a little bit about what that means. But let's read the dictionary definition first. Infrastructure as a service, IaaS. It's interesting that they abbreviate it like this, but as a service, is an instant computing infrastructure provisioned and managed over the internet. This is a very loaded definition. Sometimes I'm just wondering, why did they put the definition, like the word in the definition almost? Well, what is it? Let's talk about it, right? So actually the first company I worked at, it's NetApp, and NetApp actually owned data centers, all right? So what is a data center? Maybe you guys have heard of it, maybe you guys haven't. A data center actually looks like this. It's a room with just computers, racks and racks of computers. And so these are all like motherboards, right? So your computer, your laptop, your PC, your desktop, all of those things, they're just motherboards operating. And here you can see that it's been extracted out and they're put into what we call rack, right? And so it's racks and racks, and the data center is just racks and racks of these. And so what does it do? Well, a little history lesson, and this may or may not be super accurate, but don't hold me to it. But let's say you're trying to start a startup, or you wanted to create something and put it on the web. You can actually use your own machine. You can use your own MacBook. You can use whatever computer that you have and make it widely accessible to the world, to the cloud. And that actually might be expensive. Let's say you're like Reddit, or maybe you're going to become the next Reddit. You need more machines. Well, there needs to be an easy way to rent more machines, right? And so that's really what this idea of infrastructure as a service is. It's a service because you're renting more infrastructure. You're getting more infrastructure for cheap, or you're maybe just renting it. You don't want to buy the entire machine. And so that's why it's a service, right? And it gets provisioned. Provision is like you're spinning up a new machine whenever you want, right? And it's managed over the internet. Point being that you can issue some commands in your terminal that we went through over here. And you can just tell Amazon AWS or GCP or any of those places, hey, I want to rent a small computer, or I want a very, very large supercomputer, and I want to rent it for a couple seconds or just till this function is done running. So that's what a data center does. That's what a lot of these terms are doing, right? Or what they mean. So infrastructure as a service, hopefully that makes sense. I'm going to take a pause. It is a pretty loaded term. I hope that answered some things. Okay. All right. So what do we actually execute on these data centers, right? I kind of talked about this a little bit earlier. In this example in Alexa, right? And, we looked at some of this code where an event is sent, and that event may be you talking, and maybe you typing something, right? And maybe those events need to go to the cloud somewhere, right? Cloud is still this invisible thing. And we'll take another look at it. Maybe you guys can see what a request looks like and things like that. But we have what we call server software. And server software it's a piece of software that runs on this machine that you rented, right? So I'm going to show you guys an example of what that looks like. So renting a little machine, let's take a look at what that code looks like, just so you guys aren't lost here. Managing Amazon EC2 instances. So those little machines are called EC2 instances for Amazon. There are tons of other terms for other providers. If we scroll down a little bit, you can see there's packages we need to import, Python, very standard things. Every language has these things, right? We're just going to, let's see, EC2 right here. And what are we going to do if the action is on? Maybe it's processing some things, and we're just going to start instances, okay? So EC2, synonymous with instances. You're essentially saying, AWS, give me a machine, start it up, I want to play with it. Okay, that's all it is. And then they tell you some instructions on how to reboot that little machine. If something goes wrong, or if you want another one, you can always create a new one. This is the simplest example of renting that machine. And as you imagine, renting a machine, you have to pay for it, unless you have special discounts, and those definitely do exist. So I want to throw that out there. So these little machines, once you spin them up, they're somewhere in the cloud. They're somewhere actually just running on one of these little motherboards and machines, right? And what you're saying when it comes to server software is that one of these machines, let's say you rented out this top one right here, this top motherboard. If you rented out top one, technically you might not even rent out the entire thing. You might just rent a portion of that. That's why we call it virtual machine sometimes, right? So you're renting out a piece of that pie, right? And you're running code on that. It's a server. This is what we call a server. When you rent that out and you run a piece of your own code on it, that's what we mostly call a server. And oftentimes it will, for the example of the Alexa example that we went over earlier, it's going to execute that code that handles that event, right? So it's going to actually execute this code here. So that's what the server software is responsible for. Sometimes though, when it executes this code, maybe it is the case that you see here random.choice, and we're going to pass it some variables. I'm assuming that you guys know this. Maybe I'm going too fast, hopefully not. We're going to run this function, and we're going to pass in this variable, data.cityData. Sometimes the data is so big, and sometimes it's in what we call a database, okay? And a database is essentially a giant place that you store things, right? And it's, it's nothing more complex than another machine that has a ton of space, like RAM, gigabytes, and all of those things, right? So I don't want to go into too much detail, but hopefully that at least gives a good understanding of what that is. So it's going to, as the database, is responsible for responding with the data in which the server itself will use to make that choice and then respond to whatever you typed in, right? Hopefully that was not confusing. I'm gonna take a pause there. Okay. All right, so let's talk a little bit about what a request looks like, because it's kind of cool. Sometimes if you guys go to google.com, if you guys have ever seen this, you can right click and click inspect here. And it opens up this thing that's called the Google Chrome Web Developer Tools. Obviously, I'm using Chrome right now. You can do this in Firefox. You can do this in Safari. You can do this in most of the major browsers, but Chrome is the most oftenly used, right? So what you can do is, if you guys have ever seen this before, right? So you can see I looked up the weather today. But if you go to the Network tab, you can type in things, right? So as you type, right? Hi there. What is Google doing, right? Well, if you look down here, these network requests, you can see that hi is right there. I typed in hi right there, right? I think maybe it is the case. Hold on, let's see if we can expand. I kind of don't really have good. Oh, if you hover over it, you can see Q equals hi, and then %20 THER, right? It's trying to capture everything that I type in. Every time I type in a character, this is an event, right? That's what I was talking about earlier. Maybe the trigger point is you talking, so you can actually click this and you can talk, right? And you can allow it to use your microphone. Oh, what happened? Something happened. How to use my phone, what happened? Okay, so it registered some things, right? And actually Google is doing a lot of things in the background. It's trying to process whatever you typed in or whatever your event is. You can see that event in the network tab. You can see the results that it's trying to, so I'm just gonna clear this. Hi there, right? So we're just gonna pick one, and you can generally, if it's gonna allow me, see what that response is. Okay, maybe not, but all right. Well, you can, and maybe you can look at it later. I don't want to take too much time here. But you can actually see the results that come back directly from Google. And so what's happening is it's taking your event, giving it to google.com. Google.com is gonna run through their server software that's gonna process your requests, right? Process your requests similar to this one earlier. It's gonna handle your request. Maybe you'll look up in their database and say, hey, are there any results that look similar to this? It actually does way more under the hood, but I'm just simplifying it, oversimplifying it. And it's gonna return your results. So hopefully that's a quick web understanding. But I guess all of this is to say that Python, you can use that to create and manage a lot of these resources. You can spin up these machines. You can actually create your own little Dropbox, if you will, using the same tools. So they have a lot of services. I would encourage you guys to take a look at that if you guys are interested. I'm gonna pause there, 3 seconds. Okay, cool. I'm gonna go on to the next one. So browser web application automation. So if you guys have heard of Selenium or this idea of web scraping, well, maybe 1 or 2 weeks ago, I'm not sure how many of you guys were trying to buy the PS5. One of my friends asked me to buy one. And I was actually on the page. You can see, due to very high demand, actually, if you were waiting at every hour that it was open, every minute, it was loaded. Like the site would not even load. And, you can go to Walmart. It's actually, I took a screenshot of this today. But actually, if you go to this article that I posted here, you can see that there's a lot of bots just doing this. Oh, shoot, I have an ad blocker. That sucks. Well, you can look at it later. And essentially, there's these bots that scrape the internet and scrape and or crawl, that's a better term, the web to do things like this, like buy PS5s, buy all the PS5 so you can resell it for later, right? So that's one of those common functions of what these things can do, web scraping and crawling. Scraping is a more generic term for, let's say you have data on Wikipedia that you really like, maybe for a school project, you want to get all the titles for a particular type of article. You might create a web crawler that goes to all these Wikipedia links and scrape just that title. Scrape meaning pulling that title and aggregate it somewhere, put it into maybe a data file, right? So in the example of this PS5, I guess we're going back to this, we're talking about web scraping and or web crawling. And if you guys have ever seen a CAPTCHA, there's a reason for that, right? We need to, they think it's a bot. And so they need to add these CAPTCHA things for you to try to break and make sure that you're a human, which unfortunately doesn't always work. So I'm just gonna put that out there. I'm not sure if we have enough time, but I have a quick Giphy that shows, here's some code, right, of Python code, and someone executing this Selenium driver, and hopefully you guys saw that, maybe you didn't, it's actually very quick. But here's the code, and someone's running Selenium on their machine. And what does it do? It actually, if you look on line 5, I can't scroll to it maybe, or actually, can I? Okay, actually right here on line 5, I don't know if you guys can see it. Driver equals webdriver.chrome. It's running on someone's local MacBook machine. And we're gonna maximize the window. You can read it, right? And it's gonna go to this website. It's going to type in, or it's going to find some of these elements on the page, and it's going to start typing in some things. It's going to execute a script or something like that, and it's going to click a button. So if you watch the video again, what is it doing? It's going to that website, it's typing in a bunch of things for you, and then it's going to click send, right? So here's an example of what that web crawler is, and I just wanted to show you guys what that code looks like. So if you guys are interested, obviously you might get rate limited, and there are other things maybe we could talk about later. So I copied and pasted another example of that code here. I'm going to take another second to pause. Does the mouse scroll around with the program? Yes, and that's creepy. Actually, it takes over your whole screen and it clicks for you. There are actually programs out there that's called headless programming, where it's running kind of under the hoods without a mouse and without a browser opening. It's very interesting. A lot of times these are used for tests, right? So if I were to create even, let's say, a simple part of Facebook, right, and I wanted to test that, sometimes they'll create what we call integration tests that just type in facebook.com, go to that specific path or URL, and it'll click the things that I just, I want to test, type in things that I want to type, and I can just leave it there and it'll just do it for me, right? So a lot of these things are automation. You don't want to do it again. So you write the script and hopefully it will just do it for you in the future. I don't know how useful it is. Sometimes the web changes a lot. The web pages change a lot. So you have to update the scripts continually if you were to do something like this. Okay. So I have 4 minutes, 4 minutes, 3 minutes. Okay, cool. I'm gonna go through as fast as possible. Slackbot, all right. Hopefully you guys have seen Slack before. I posted some sample GIF here. We're just gonna look at it, but you can actually program, Slack to tell it, create a bot that responds to user input, similar to what we talked about. An event is whatever you typed in, and you can ask it to just give a random fact. This is a simple Slack integration, right? And there's some code here. I don't know if I'll go through all of it, but there is stuff that you can call and you can tell it to create new messages wherever it is. Slack API basics. You can tell it to tell you all the channels that exist, things like that. How many channels exist in this Slack workspace, I think that's what it's called. And you can send automatic messages every time something happens. So it's pretty cool. Should I take the question, or maybe I'll reserve this for later. I'll get back to your question later. For pandas, I want to go through this real quick. Pandas is like the de facto way in Python to interact with data. So a lot of times maybe you're interacting with CSVs, you want to read CSV as input, you want to write to CSV. You actually can convert them into this temporary data type that's called a data frame. And it looks like this. You can print it out. There's different things that you can handle. I don't want to go into too much of this. Maybe you guys will at some point in your lives. All right, and then lastly, there are, if you guys have worked with WordPress at all, Django or Python. Django is a framework that uses Python, so maybe that wasn't the best thing to put. But you can actually create your own WordPress alternatives or use their alternative software to create essentially a blog managing site, right? If you guys have used WordPress before, so you can see you're laying out what the website looks like, right? You have a home page, you have an about page, you have blogs, and yeah. So I just wanted to point out that these are some things that you can do, and you guys can read up on it if you guys are interested in the future. Lastly, for resources, so let's go through that. I already mentioned this at the beginning, but Python generally is already installed on Mac. There's definitely a lot of versions. There can be tricky situations, but for the most part, if you have a Mac, it'll be easy. For Windows, you just have to go to Python, just search up python.org, I think. I don't know. I think that is. Yep, you can download it for Windows as well. So it's all very easy, accessible. Another useful resource is the Google class. This is actually really old, but it's so useful. This was probably the first course or first thing that I used to learn Python. Definitely timeless tips in there. I would recommend going through it. It's probably like 3-day tutorial. It's probably like 3 or 4 hours, I don't remember. In terms of Python IDEs, PyCharm is probably the de facto. Some people use Sublime Text 3. I can't show you guys too much right now, but maybe if we have time later. And I just wanted to point out that my company is hiring for internships. So if you guys are interested, feel free to reach out. And hopefully I ended on time. Yes, I did.
Awesome. Thank you very much, Daniel. I'm pretty sure everyone really appreciates it. Okay, so we'll get the ball rolling. Warren, if you're able to screen share. And also to everyone else, if you have any questions, also feel free to put it in the chat. Daniel will be sticking around probably till around his 7:30, so yeah. Okay, cool.
Okay, so hi, I'm Warren. I'm a freshman at Baylor in the Academic Notes Committee, and I'll just briefly be going over a really brief introduction to C++. So just real quickly, what we'll cover, I'll give a brief overview of what it is, some uses of C++, compilers and IDEs, just some general info to know about those. Programming basics, which is where we'll spend most of our time. It's getting to understand how to code with C++. And then lastly, how to get started with C++. So like some resources that you can use to teach yourself, and then also some other resources like the IDEs that we'll go over that can actually let you code in C++ yourself. So a quick overview of what C++ is. It is a general purpose programming language, meaning that it's used in a wide variety of situations. It can be used for a lot of different purposes. It's an extension of the C programming language, which dates back like to at least the 1970s. So C was the original language, and then C++ was basically made as an improvement to C, although C is still used as well. But generally, C++ is seen as able to do a lot more. C++ uses compilers, which we'll go into more in a second, but those are basically what read your code that you type. It reads it and tells the computer what to do with it, really. And then some of the features that C++ has that makes it unique, at least from C, is it has objects, which we briefly touched on with Daniel's presentation. It's like it lets you create kind of your own classes, or like you basically have control to make your own things in the program. So you can make like basically like different simulations, like if you wanted to make a T-Rex, for instance, like we saw. And then it also has functions, which are just like chunks of code that you can repeat over and over if you wanted to call the same, if you want to do the same task again. And then it has lots of other features too, but those are some of the things that C++ can do. And then some like real world applications. C++ is known for its performance, its efficiency, and flexibility. So this is what distinguishes it from some other languages out there. It's excellent for resource limited applications and large systems. So like anything that's maybe limited on resources or really large projects as well. Some examples would be used in desktop applications, video games, servers, and again, especially performance critical applications such as telephone switches and even space probes, like we see in the pictures here. Now, really quickly, compilers. This is just something to know. It's good to know before you actually get into your programming. It's good to know like how things are working behind the scenes. So compilers are what produce the runnable programs out of the source code that you type. So you're going to type your code into your compiler or an IDE, and then when you compile the code, the compiler is basically just going to convert your code into a more simple language, like machine code or machine language that the computer can actually understand. Because like if you type, x equals 5, the computer doesn't understand what that means. It has to be converted into a more simple language, and that's what the compiler is doing. Something else the compiler does is it checks your errors for you. So whenever you compile your code, if you made some mistake, it's not going to let you finish and run that code. If you made some error, you're going to have to correct that, and the compiler will point that out for you. So that's something else that compilers are good for. And then some of the companies that make compilers for C++ are Microsoft, Intel, Oracle, IBM, and others. And then one last thing before we get into the actual programming is IDEs. These are integrated development environments, and these are basically what you're actually typing your actual code into. And we'll see an example of what that looks like in a second, but they come with compilers in addition to many other features. So they compile your code and read your code and convert it into machine language for the computer to read, which is what the compiler does, but then it also does other things like it can provide hints and suggestions for you as you're typing, like it can autocomplete your code. So say you named some variable and then early on, and then you're in the middle of typing that same variable again, it will autofill that name, kind of like spell check on text or something like that. It can also autocorrect your code. So if you misspelled one of your variables that you made, it could correct it for you. Again, kind of like spell check on a text message or something. It checks for errors for you, kind of better than compilers do, and more. So IDEs are basically just make coding a lot easier for you. And at the end, I'll show some examples of IDEs that you can download for free that can really help you start coding in C. But now we finally get to what's really interesting, some programming basics of C++. So obviously we're going to be typing code, and the compiler, which we talked about, it reads your code line by line, left to right, top to bottom. So kind of like how you would read a book, I suppose, like a page. The compiler can only read things one at a time. So it just goes down your code, kind of like how you would read a book. And then you type each line in your code into your IDE, similar to how you would type into a Word document, if you want to think like that, like one sentence on each line. However, there are some very key differences. You're not just typing anything you want into your IDE. You have to follow very specific syntax rules of C++, as you do with most languages, including Python, but C++ is a little more strict. Like, for instance, one of the most important things to know is that almost every line of code that you type you'll want to end with a semicolon because that tells the compiler, oh, this is one task and it's done. It's kind of like a period in a sentence. It's basically telling the compiler, oh, this is done, move on to the next thing. So like it knows when to stop reading each task that you're telling the computer to do. And then generally you would have one line of code, or one action would get its own line of code. So in most cases, you're not going to type multiple tasks with multiple semicolons in one line. Usually you just give one task its own line, so that's easier to read. So basically when you're done typing a line, you're going to end it with a semicolon and then hit enter and move on to the next line and keep doing that. Now we can talk about variables, which is like the very most basic things you'll be using in, no matter what you're programming in C++, no matter how advanced it is, you're probably going to be using variables of some kind. And variables store different data types. So like on your keyboard, we have numbers, characters, and there are different variables or variable data types that are assigned for each of those. That we'll get into in a second. But basically, a variable, you can create a variable by declaring the data type and then giving it a name. So for instance, you would have an int, which stands for integer. So these would be numbers. So int, and then you can name it my age, for instance. And then of course, we always end it with a semicolon to let the computer know, the compiler know that we're done with that line of declaring a variable. So int my age. And then you could also be even more specific by giving your variable a value by typing the equal sign, and then the value you want it to store after the equal sign. So it could look something like this. A double, 5 digits of pi. So the double is the data type, and then the name is 5 digits of pi. It could be any name you want. And then equals, so you're assigning the value of 3.1415, so a decimal number. And then again, we end with a semicolon. And if you look at a few bullet points up, I said use camel case. That's a really helpful way to name your variables. It's basically like just a rule you generally want to follow. So if you notice, the first word of our variable name is lowercase, and then each subsequent word of the name is uppercase, like 5 digits of pi. So that basically just makes it easier to read because variable names can only be one word. You can't have spaces in between. So if you wanted your variable name to be multiple words, it's going to have to combine, truncated into one word, but you can separate it by using uppercase for each word in your variable name. You could also use underscores to separate the words, but camel case is just generally used. Now, these are the data types I was talking about, at least some of them. So we have an int, which stands for integers. So any integer number, you would use int to store those. So like -12, 0, 1. Doubles are also for numbers, except this is for decimal numbers. So like 0.04 or 2.718 or like pi, like we were doing up above in that example. And then the last two, char, that's for individual characters. So basically any character that you see on your keyboard, you could store that individual character by itself just as a char. It stands for character. So any individual character, but then if you wanted to make, combine a series of characters, like to make a word or a sentence even, that's when you would use the string, or last data type down there. So this can store basically a series of characters or numbers. Basically, you can type anything on the keyboard and that can be stored as a string. So you can have a single word like hello, or a series of words and spaces like how are you, or something like that. And then the only two things to know about chars and strings is that when you declare a char, you put single quotes around that character that you want to store. And then for strings, you put double quotes around the whole word or sentence that you want to store. Operators. So in math, we have lots of operators like plus, minus, multiplication, division. C++ also has these operators, but a lot more. You notice that one of the operators it has is that double plus sign, and that's called the increment operator. So it basically just increments something. It increases it by 1. So that's kind of why C++ is called C++, because it's 1 better than C, the predecessor language. So it's kind of like a play on that. But we basically use these operators on our variables that we declare, like in the last slide that we went over. So this is how you can manipulate those variables that you declare. So an example, if we had some variable named total price, we'd say total price equals a variable quantity times unit cost. And then that would, so those are 3 different variables. And then we're using an operator on 2 of them to assign a value to the one on the left, total price. And then you could do more complicated stuff. Usually parentheses are a good way to separate your operators to make it easier to read and to say and to tell you or tell the computer what you want, which operators you want to happen first. And then again, total cases plus plus, that would increase the value that total cases is storing by 1. So those are just a few operators that you can use on your variables. Output, so if you want to print your output or print your variables to the screen, there's a way to do that. It's called cout. So C++ has a stream object called cout, and this accesses the screen. And to print to the screen, you use the insertion operator, which are those 2 double arrows, the less than arrows, 2 of those. You separate those between each, or you put them in between each thing that you want to print out. So if we had a variable average height, we could print that out by saying cout, so that's the first thing we type, and then equals, we could do a string, the height is, and then average height, and then another string, feet, and it would print out the average height is 5.5 feet. So that's one way to print out information and your variables to the screen. One last thing to know about cout is that you can use end line or end L at the end of your cout statement to move to the next output line afterwards. So it's kind of like hitting enter at the end and we'll move to the next line. So if you said cout, this is, and then end line, and then another cout, a test, you print this is a test. So you'd be able to print to 2 lines. So that's basically what end line is for. And then similarly, we can do input. So you can also read from the user's keyboard if they type something. And for this, we use cin, which is similar to cout. And instead of those less than arrows, we use 2 greater than arrows. So it would look something like this. We had a variable int user age. We could say to the user, enter your age, and then we could read in what they type, and then store that in our variable user age. So the cin basically just reads whatever they type and stores it in whatever those 2 arrows are pointing to, so our variable user age. So if we said enter your age and we typed 21, then it would print out you are 21 years old. One last thing is comments. So you can type stuff that the compiler won't actually read using comments. So this basically lets you explain what your code is doing. So if you had, this is really useful for long code and complex code. So you could use comments to explain, oh, this is what this is supposed to do, which would help someone else understand your code if they were reading it or looking through it. So we have 2 types of comments. We have the single line comments, which are just 2 backslashes. And basically, this lets you type anything you want on a single line. So everything after the 2 double slashes, you can type and the compiler will ignore. So you can type anything you want. And then we also have multi-line comments, which you use those 2 series of characters. So you would type the first one, and then you can type anything on as many lines as you want until you get to the end. And so those are just comments for lots of lines if you had a lot to type. Other features of C++ that I haven't gotten into now, but you can research on your own are if-else statements, loops, arrays, functions, classes, and a lot more. But we just went over the basics of variables and operators and how to print those and to the screen and read from the user, because you're going to be doing those things pretty much in all cases that in any project that you work with. These are just more advanced features that C++ has that are also very useful. So getting started with C++, some resources if you wanted to continue learning C++ for yourself, which I highly recommend. There are a lot of different websites out there, but one that I really like is Geeks for Geeks. I even go on the site a lot when I'm doing my own projects when I need help, because it explains things really well, and it usually covers just about everything that I would need help with. So all of these are good, but Geeks for Geeks is just my personal favorite. And then lastly, some compilers. So if you wanted to start coding by yourself right now, you'd go online and type in Google like C++ compiler, and you'll find some websites right off the bat that you can just start coding in right now. But generally, though, you'd want to use IDEs, which we talked about. Those really are more designed for real projects that you need to sit down and work on, and they can take time. You want to save them and work on them later. In those cases, you want to download an actual IDE to work on. And some examples are Code Blocks, which is free. I use this one personally, and I really enjoy it. It's really very helpful. But then others are CLion, which is also free if you use your school email. So you just have to sign up as a student, and they should be able to let you download it for free. But yeah, each of those are really good. So I would definitely recommend downloading one of these IDEs before you start jumping into coding, because these can be really helpful. So that's all I had for a brief intro on C++, but if there are any questions, I'd be happy to answer.
Awesome. Thank you, Warren. I'm going to talk just for a little bit, but if you guys have any questions, feel free to chat or unmute yourself and talk to Warren. Let's see. Warren, is it okay if I stop the screen share?
And then... yeah. Mm-hmm.
Okay, awesome. Let's see.
I can do that.
Yes. Okay, perfect. So thank you for coming. Let me share the last part. Oh, right. Okay, Parker, you can take over this part.
Okay. So just want to thank Daniel and Warren for coming out and presenting y'all's ideas and your knowledge. That's great. And for our members here, this is the QR code, or let me put it in the chat real quick too. Okay, I just put it in the chat, and so y'all can look at that, and then make sure to double check your points because the semester is coming to a close. So if you have any problems, make sure to email Burst.